Okay, now we are going to study the next part, that is nothing but related terms and their definitions, means the terms and the definitions regarding the metallurgy. Now in that case we have to study the first term, that is nothing but the system. First term is system. Second term we have to study, that is nothing but the phase. Next is variable. Next is component. Next one alloy. Next one solid solution. Now the system means what? That as we know that whatever metal we are getting, suppose if I want the ferrous, then that ferrous I am collecting from the ore or I am extracting from the ore, and that ore I am collecting or extracting from the earth. And that earth is nothing but the universe, we can say. So in case of system, what we can write, that the metal whatever we are extracting from the ore, and that ore we are getting from the universe, so the system is nothing but Fe, we can say, and that Fe we are getting from the ore, that ore we are getting from the universe. So system we can define, that is the part of universe. System is nothing but the part of universe. Whatever we are going to study, that is nothing but the system. Now phase, as we know that the material possesses different types of the phases, means what we can say, the material possesses the liquid phase, the solid phase, and we can say gaseous phase. Now this phase means what we can say, that is the homogeneous, physically distinct and mechanically separable part. Means what we can say, that phase means what we can say, that is the homogeneous, means whatever mixture we have taken, that is the homogeneous mixture. Physically distinct means we can physically identify the different phases, or we can say the different state of the material, and that is mechanical separable, means with the help of mechanical processes we can separate out these different types of the, what we can say, the state, and these all are the part of system. This all are part of the system. So that phase we can define as, that is homogeneous, physically distinct and mechanical separable part of system. Okay, next we have to study, that is nothing but the variable. As we know that the different three variables are there, that is nothing but temperature, pressure and concentration. Temperature, pressure and concentration. Now when we change the temperature, when we change the pressure, when we change the concentration, then we are getting different types of the phases. Let's take one example of Fe. Suppose if we consider the ferrous, then in that case when we are heating that ferrous up to 910 to 1400 degrees centigrade temperature, then we are getting the ferrous, but that particular ferrous having different types of the, what we can say, the structure. Means initially at room temperature we are getting alpha Fe, that is alpha ferrous we are getting, Here we are getting the gamma Fe, that is gamma ferrous we are getting, and when we are hitting that above 1400 degree centigrade temperature, then we are getting the delta Fe, and that particular microstructure, or we can say the crystal structures are, here we are getting the BCC structure, here we are getting the FCC structure, and again we are getting the BCC structure. It means that when we are changing the variable, means here we have to consider the variable as a temperature. When we change that temperature, then we are getting different crystal structure. Like that, when we are changing the pressure, when we are changing the concentration, we are getting the different properties of material. That is nothing but the variable. Means in next part we are going to study the next part, that is nothing but the Gibbs phase rule. In that we will clear these three terms, that is where we have to change the temperature, pressure and concentration. That we will see in the next part. Next we have to study, that is nothing but the component. So the meaning of component means what we can say, that the element present into the system. Means in case of component, what we can say, element present into the system. Element present into the system. Element present into the system means whatever that copper aluminum alloy, like that system is nothing but the component we can say. Next one is the alloy. Alloy means what we can say, that is the mixture of two or more material. The mixture of two or more material, that is nothing but the alloy. That is nothing but the alloy. Now in case of alloy, what we can write here, we can write alloy, that mixture of two elements. Means suppose if we consider metal A and metal B, then in that case, if the metal A is having more percentage and metal B is having less percentage, then in that case this particular metal A is known as parent metal or base metal or solvent, and this metal B is known as alloying element. Or we can write that is nothing but the solute. That is nothing but the solute. So here we can clear the two terms, that is solvent and solute. Now solvent means what? Having more percentage. Solute means what? Having less percentage. Let us, if we consider one example of gold, for example gold plus copper. Now as we are observing different types of the ornaments like rings, necklace, bangles, in that necklace, bangles and rings we are adding the copper which is having the less percentage. So in that case, whatever alloy we are getting, these two when we are adding, then we are getting the alloy. In that, gold having more percentage while copper having less percentage. So we can say that whatever alloy we are getting, that will shows the properties of gold. So that is nothing but the alloy. Next we have to study, that is nothing but solid solution. Now in case of solid solution, what we can say, solid solution, that is again we can take one example of mixture of two metal, that is metal A plus metal B. Then what we can write, suppose this is the atomic site of metal A Suppose this is the atomic site of metal A. Then in this atomic site of metal A, if we add the atoms of B, means suppose if I add the atoms of B in that, okay, then I will get the mixture of these two metal. That is what we can draw. Like this. So here what we can write, these are the metals of B, okay, and these are the metal of A, and this is B. Okay, means what we can say, the atoms of solute, because B is having less percentage, A is having more percentage. So this is known as a solvent and this is known as a solute. So when we add the atoms of solute or when we distribute the atoms of solute into the atomic site of solvent, then it is known as solid solution. In case of solid solution, there are main two types of solid solution. First one, that is substitutional solid solution, and second one, that is interstitial solid solution. Now in case of substitutional solid solution, again there are different two types of solid solution. First one, that is nothing but ordered substitutional solid solution, and second one, that is disordered substitutional solid solution, or this particular order we can say that is regular substitutional solid solution, and here we can write as a random substitutional solid solution. Now in case of ordered substitutional solid solution, what we can say, that the atoms of solute are distributed orderly into the atomic site of solvent, that is nothing but ordered substitutional solid solution. Means what we can draw, suppose this is the atoms of A, that is in case of atomic site, and these are the atoms of B, again A, again B. Okay, suppose again one line if we draw. Now in that case, these are the atoms of B, that is nothing but the solute. So here we can see that after A there is a B, after A there is a B, after A there is a B. So like that ordered structure or regular structure we are getting. But in case of disordered substitutional solid solution, suppose these are the atoms of A, then here randomly anywhere we can get the, or we are observing the atoms of B. So this is nothing but disordered or random substitutional solid solution. Now in case of interstitial solid solution, how we can draw? Suppose if the atoms are present into the, what we can write, into the interstitial site. If we are observing atoms into the interstitial site, suppose if I draw like this, in that case, if I am observing atoms here, that is nothing but, in case of interstitial site, then it is known as interstitial solid solution. Okay, so in case of solid solution, what we have studied, that two types of solid solution: substitutional solid solution and interstitial solid solution. In substitutional, again there are two types: ordered and disordered, regular or random. In case of regular, the atoms of solute are distributed orderly, and in case of disorder, anywhere into the atomic site of solvent we are observing the atoms of solute. And last one, that is nothing but interstitial site. At the interstitial site, if we are observing the atoms of solvent, then it is known as interstitial solid solution. Okay, thank you. Next part we will see in next lecture.